Now this is the Pythagoras theorem. Now we are aware of what the Pythagoras theorem is, that in a right angle triangle, if you have a right angle triangle, this is the base, this is the perpendicular, and this is the hypotenuse. Now the Pythagoras theorem states that in a right triangle, the sum of squares of the base and the perpendicular will give you the square of the hypotenuse. That means the base square plus perpendicular square is equal to the hypotenuse square. So we have to prove that AB square plus BC square equal to AC square, right? For this proof, what we do is we are going to draw a perpendicular BD to the hypotenuse. From B, you are drawing this perpendicular. So this is our construction, that's why it's in dotted lines. So what is given to us is that angle B is 90 degrees and we have to prove that AB square plus BC square equal to AC square. So what we do is take the triangle ADB, this small triangle ADB, and the big triangle ABC and prove them similar. So if you take ADB and ABC, angle A is common. Angle ADB and ABC are 90 degrees each, right? So ADB and ABC will be similar by AA criteria, AA. Two angles are equal, right? A is common. This is 90 and this is also 90. So once the triangles are similar, what happens is that the sides are in proportion. So we get AD by AB equal to AB by AC. Corresponding parts of similar triangles are in proportion. Now you cross multiply this, we get AB square equal to AC into AD. Now we can repeat the process here. We can take the triangle CDB and triangle CBA and prove them similar by AA. So we need not prove it. We can say similarly triangle CDB and CBA are similar. CDB and CBA, right? So if the triangles are similar, then what will happen? The corresponding sides are going to be in proportion. So what will happen here will be BC upon CA is equal to CD upon BC. Okay, so whatever we are taking here, the corresponding we have to take here. So I am taking BC, I will take CA, CD and CB. Okay. Now we cross multiply this, we get BC square equal to CA into CD. So we got the value of AB square, we got the value of BC square. Now we will add both. So we will get AB square plus BC square is equal to AC into AD plus AC into CD. Now if you notice here, AC is common. We will take that AC common. So what will happen in the bracket? We will get AD plus CD. And AD plus CD from the figure, if you see, AD plus CD is AC. So I am replacing this with AC. So we will get AC into AC, AC square. So therefore we get the final AB square plus BC square equal to AC square, right? Hence proved. So this is the proof of the Pythagoras. So in the exam they can ask you state and prove Pythagoras theorem. So the statement also you should learn up. And this is the proof of the Pythagoras theorem. So this is the third theorem in the chapter which has to be learned with proof. The first was basic proportionality theorem. The second was ratio of areas of two similar triangles is equal to the ratio of the square of their corresponding sides. Now this is Pythagoras theorem, and after this we will be doing the converse of Pythagoras theorem.